Python operators are fundamental building blocks for writing expressions and performing various operations in Python. They are used extensively in Python programming for calculations, comparisons, logical operations, and more. In Python, operators are special symbols or keywords used to perform operations on variables and values. Here's an overview of the main types of operators in Python. 1. Arithmetic operators. Perform mathematical calculations like addition, subtraction, multiplication, division, etc. 2. Comparison operators. Compare two values and return Boolean, true/false, results based on the condition. 3. Logical operators. Combine Boolean values using AND, OR, NOT to make conditional statements. 4. Assignment operators. Assign values to variables using symbols like equals, plus equals, equals, asterisk equals, etc. 5. Membership operators. Check if a value is present in a sequence, list, tuple, string, etc., using in and not in. 6. Identity operators. Check if two objects are the same object, is, or different objects with the same value, is not. 7. Bitwise operators. Perform operations on the binary representation of numbers, less common in everyday coding. Python operators are used extensively in real-world programming scenarios across various domains and industries. Here are some examples of how Python operators are used in practical applications. Mathematical calculations. Python operators such as addition, subtraction, multiplication, and division are used in mathematical calculations. For instance, they are employed in financial applications for calculating interests, in scientific computing for numerical simulations, and in engineering for modeling and analysis. Data manipulation and analysis. Python's operators are vital in data manipulation tasks using libraries like NumPy and Pandas. These libraries leverage operators for performing operations on arrays, matrices, and data frames, such as element-wise addition, subtraction, multiplication, and division. Conditional statements. Operators like comparison and logical operators are fundamental in conditional statements. They are used to evaluate conditions and control the flow of program execution. Real-world examples include decision-making processes in business logic, validation checks in web applications, and filtering data based on criteria. String manipulation. Operators such as concatenation, plus, and repetition, asterisk, are frequently used in string manipulation tasks. They help in combining strings, repeating characters, formatting output, and processing textual data in applications like text processing, parsing, and document handling. Iterative operations. Python's membership operators, in, not in, are utilized in iterative operations such as iterating over sequences like lists, tuples, and dictionaries. These operators facilitate searching for elements within data structures, filtering elements based on specific criteria, and performing set operations. Bitwise operations. While less common in everyday programming tasks, bitwise operators are utilized in low-level programming, network protocols, and cryptography. They are used for manipulating individual bits within binary representations of numbers, implementing data compression algorithms, and optimizing performance in certain scenarios. Object-oriented programming. Python's operators can be customized through special methods, often called magic or dunder methods, in classes. These methods enable user-defined objects to support built-in operators, allowing for custom behavior when using operators with objects. This feature is extensively used in object-oriented programming for defining classes that model real-world entities and their interactions. Here are some common real-world applications of Python operators across various domains. Data science and analysis. Arithmetic operators, calculating means, standard deviations, correlations, financial metrics, scientific simulations, etc. Comparison operators, filtering and sorting data, identifying outliers, comparing performance metrics, creating data visualizations. Logical operators, combining multiple conditions for complex filtering and analysis, conditional data transformations, implementing decision-making algorithms. Membership operators, checking for the presence of values in datasets, feature selection, data cleaning and validation. Web development. Arithmetic operators, calculating prices, discounts, shipping costs, user-specific content, managing inventory, handling financial transactions. Comparison operators, user authentication, access control, content personalization, form validation, conditional rendering of web pages. Logical operators, handling different user inputs and actions, creating dynamic web content, implementing search algorithms. Membership operators, checking for user roles or permissions, handling user input validation, accessing elements in data structures. Game development. Arithmetic operators, calculating scores, movement physics, health points, resource management, damage calculation in combat systems. Comparison operators, collision detection, game logic, player interactions, AI decision-making, win/loss conditions. Logical operators, combining multiple conditions for complex game mechanics, implementing branching storylines, responding to player choices. Automation and scripting. Arithmetic operators, calculating file sizes, process durations, system resource usage, generating reports, automating tasks. Comparison operators, triggering actions based on system conditions, file management, error handling, conditional execution of tasks. Logical operators, combining multiple conditions for advanced automation workflows, making decisions based on system state. Machine learning. Arithmetic operators, implementing model calculations, updating weights and biases during training, evaluating model performance. Comparison operators, comparing predictions to actual values, calculating loss functions, making decisions based on model outputs. Logical operators, combining multiple conditions for complex model architectures, implementing decision trees and other algorithms. Additional examples. Finance, calculating interest rates, loan payments, investment returns, risk assessments. Scientific computing, modeling physical phenomena, data analysis in physics, chemistry, biology, and engineering. Education, creating interactive learning experiences, grading assessments, simulating experiments. Key points. Operators are fundamental building blocks for creating Python programs that solve real-world problems. Understanding how to use operators effectively is essential for writing efficient and accurate code. The choice of operators depends on the specific problem being solved and the desired outcome.